Welcome to the Databricks Skill Builder series. We're glad you're here.
Hello, everyone. My name is Grant Doyle. I'm a solutions architect with Databricks, and today we'll be talking about a newer offering in Lakeflow Connect, Zerobus Ingest. We'll do a high-level presentation on what Zerobus Ingest is, how it can fit into your architecture, and then towards the end, we'll do a quick demo to show it in action. All right, so Zerobus Ingest falls into the Lakeflow Connect category of the Databricks product lines. If you're familiar with Lakeflow Connect, we have fully managed connectors, both query-based and CDC-based, but we also have some offerings that are a little bit different. One of those being Zerobus Ingest. This is a newer offering that went GA late last year, and it allows for direct writes into your lakehouse. So I like to throw this slide up just to, if you see any other source systems that you want to be pushing to your lakehouse, check these out, contact your account team to get started with them. But today we'll be talking about Zerobus Ingest and how it can simplify your architecture with common message bus systems that you may have in place. Okay, so what is the motivation for Zerobus Ingest? It really helps simplify a lot of data streaming needs that we saw in customers around IoT, clickstream, and telemetry data. The question with all these different types of workloads is how can we offload data quickly from the source? And this was typically done by adding a staging area, commonly known as a message bus. And this solves the problem. We have your producing systems over here on the left. We have the message bus that now sits in the middle. And to get this data into the lakehouse, a lot of teams will either use Spark to read directly from something like a Kafka topic, or they will have Kafka sync the data down to their cloud storage and then ingest that into their lakehouse. So this is the common pattern that we've seen in customer accounts for quite some time. For clickstream, very similar. You're producing applications, event out to a message bus, and even for IoT use cases where machines on a shop floor are having to event data out, also leveraging message buses, maybe an MQTT broker or OPC UA. So this solved offloading data quickly from a lot of these producing systems, but now we have a lot of new problems to take care of. We have data duplication. We have data emitting from the source, now living in a broker service like Kafka, potentially living down into your cloud object storage, and then living again in the lakehouse, maybe in the form of a Delta table. This creates a lot of data duplication. It drastically increases the costs because you now have a message bus service that has to run. You now have increased storage costs and increased processing costs to ingest that data from the lake. And all of this adds a really high level of architecture complexity that data teams shouldn't have to manage just to get data into their lakehouse. So with Zerobus Ingest, we aim to solve these problems and simplify the architecture in a pretty drastic way. So for all these different types of use cases, whether it's IoT, clickstream, or telemetry, you can push your event data directly into the lakehouse by leveraging Zerobus Ingest. It's a very high-performance service. You can write your clients in gRPC and REST. We have Arrow support, and we have some coming announcements that I'll speak to at the end. Okay, so going back to our image of the common architecture we see from data producers and how we get that into the lakehouse, we'll simplify it with Zerobus Ingest. So I'll go back and forth a little bit because I want to highlight a couple things. When you simplify the architecture, we're eliminating the message bus. So we can get rid of our Kafka broker costs and complexities, as well as the connectors to the brokers. We can also alleviate any cloud object storage costs that the data might be syncing to. And another big cost saver is that you no longer have to have Spark ingesting from either Kafka or S3, your object storage. So we really simplify the architecture and allow for costs to stay low, but the ingestion pipeline to be very simplified. So just some quick customer stories highlighting their successes with Zerobus. Soracom was able to event a lot of device sensor data directly into their lakehouse. They simplified their architecture drastically, and they can now get insights in seconds as opposed to minutes with their old architecture. And if you've been following Zerobus for a little bit, Joby is a huge customer success story that was highlighted at Summit. They now event all of their telemetry coming off their manufacturing floor into Zerobus and allows for a lot of quicker insights into what's happening on the machine floor. So every factory is different. Sometimes factories are isolated and shut off from the internet, so they have to create particular forwarders to either event to a message bus or Zerobus ingest. Both can be done. But every machine is different. There's different standards between each manufacturer, and they needed a client that could simplify all of this and event that data out into Lakehouse. And they were able to do this with Zerobus. They wrote a very flexible client that was able to accept all of the different producing APIs within their factories and event that data into the Lakehouse in a very simple and scalable way. Okay. And this last example is a recent blog that was put out by our Zerobus ingest product team. They ingested a data set that contained the entire data points around the Milky Way. I'm not an astronomer, so I don't know exactly what was in this data set, but it was a very large data set, and they achieved some really high throughput, up to about 12 gigabytes per second, and they were able to process an entire petabyte within 24 hours. So this service is extremely scalable, but also very simple to write. Okay, so we're going to highlight some announcements coming out of Data and AI Summits 2026. The first being this Aero flight ingestion. So we have this in beta currently. If you want to get to use this, you can. I'll send out a link to the description of this video where you can go and get started on that. But this is really great for sending record batch data directly into Zerobus over the Aero flight protocol. And this is a really good fit when your workload has naturally columnar data and needs to be batched. And if for applications that already produce Aero data, they can write that directly into the Lakehouse without much change. The biggest announcement that I'm really excited about is the Kafka producer API. So if you're using something like Debezium to emit database change events out to Kafka, and that's how you're replicating your databases throughout your enterprise, we will now have a Kafka producer API that sits on top of Zerobus and allows all of your existing Kafka producers to write directly to Zerobus without having to rewrite anything other than the address point. And lastly is the MQTT API. So for those of you that are emitting IoT data off of your machine floors, if they emit an MQTT protocol, you'll be able to publish those directly into the Zerobus server. Okay, so a little bit about the competitive landscape. What all is out there? How does Zerobus compare? Zerobus is multi-cloud. We have AWS, Azure, and GCP. I think GCP is out by the time of this video. The slide is just a little bit outdated. We have really high throughput per connection, so 100 megabytes per second per connection. You can also scale out multiple streams to a particular table. So this architecture is very scalable. In terms of TCO, the cost is very low and the complexity is very low. And when you compare it to things like Kafka, Snowflake, Snowpipe streaming, or some of the Google offerings, we see expenses are a bit higher. The complexity is a lot more, and there's just some limitations around how you can build those clients. Okay, so that's all I had for slides. Okay, so now that we have a high-level understanding of Zerobus, I'm going to do a quick demo of what it takes to get started using it. So this link will be provided in the YouTube description, but there's a repository for our Zerobus SDK, and it comes packed with examples in Go, Java, Python, Rust, and TypeScript, and has a really good README for getting started. So we're just going to follow this example, and we'll get some data written into our Delta tables. The first thing I'm going to do is create a service principal that we can leverage in our clients. So I'm going to go to settings. If you're a workspace admin, you'll see these options over here on the left. I'll hit manage on service principals. I'll add a new one. Okay, that wasn't demo SP plus. I'm not going to choose any of these other options. I'm going to add service principal. Once that gets created, I'm going to go to the secrets tab and I'm going to generate a new secrets. Now, I already created another service principal for testing purposes, so I'm going to delete this, but just wanted to make sure that you know how to create a service principal. So now that we have our service principal made, let's go and create a table that we can push our data into. I've selected my manufacturing catalog right here, my Zerobus schema, and I'm creating this device telemetry table. You can see it's just 3 columns, pretty easy introduction. Once I have my table made, we want to make sure that the service principal has the correct permissions. Now, this is a step that I see a lot of people get wrong, and it causes some errors that mess up the client. So you want to make sure that your service principal that you created has the specific permissions outlined that I'll be talking about here. If you deviate from these at any points, you might encounter issues in your clients. This is actively being worked on to expand the permission scope. But for my service principal, the Zerobus skill builder, it's going to have use catalog on my target catalog. If we hop into my Zerobus skill builder schema, you can see the skill builder has use schema permissions, nothing else. And if we go into our table, the only permissions that we want to grant are the modified and select permissions. So make sure you have use catalog, use schema, and then you have modify and select on your tables, and you'll be good to go. Okay, so we've created our table. We've created our service principal. The access is configured. So let's build out a client. We can start by cloning this repository. I've done that locally. And again, there are examples for all the different languages over here on the left, but today we'll be using the Python example. I'm going to be in this async example proto file. I've filled out the parameters required to get started. So for the server endpoint, just take your workspace ID, the region that your workspace operates in, and that is how you get your server endpoint address. Your Unity catalog endpoint is just the workspace URL. Table name is the target table name that your service principal has credentials to. So device telemetry for us. This a little bit bigger. Okay. And then we specify the client ID and secret of our service principal that we configured when we built out our service principal. Now, this example is only going to be pushing 1,000 records through. One thing I really like about the example here is it shows all the different ways that we can write data to our Zerobus endpoint. So just real quick, in this main, we're initializing the SDK, creating the connection, but around here, we get into the different methods of pushing data. So you can push records through to Zerobus and get the offset for each individual record. Make sure that you're getting acknowledged durable rights as you continue to process data. We can ingest records with a batch offset where you get the offset back for the batch that's being processed. We can do a no wait, fire and forget. This is the quickest way to write data back to Zerobus because you're not having to wait for that callback. And the same is true for batch, fire and forget. Okay, so this example is going to write data directly into our target table. So I've ran UV sync to sync the dependencies, and now I'm going to run our Python file. Okay, so you can see that that was pretty quick. Let's hop out and do just a quick select star from our table. See, we get 1,000 records there. If I do a select count, to 1,000 records. So in this example, you'll see many different ways that you can event data out to Zerobus. When we ran that client, we initialized the SDK, we validated the table properties, and we used these 4 different methods of sending data. So with the record offsets, batch offsets, the fire and forget modes, all highlighting different ways to event data that best fits your use case. This SDK is really rich. It has a lot of helpful methods to get you to production. You can generate proto schemas based off your target table. You can also alter the target table schema based off your source data sets. There's tons of retries, authentication mechanisms that are built into this SDK. So for venting data out to Zerobus, you can use gRPC with protobufs to write data really quickly. And if your data is not as continuous, it's more batch, there's also a RESTful endpoint where we provide a REST interface for you to write data out to. So in the description of this video, we'll be putting in the Zerobus SDK link. We'll also be putting in some blog articles showing how certain customers and Databricks internally have achieved really high throughput and success with the Zerobus ingest capabilities. If you have any questions, feel free to reach out to your account team, and thanks for joining the Scope Builder.